Consumer Products by Sophie Graham. I've decided to pick television for my project. So this is a quote from 1971, which says 10% of homes still had no indoor lavatory or bath, 31% had no fridge, and 62% had no telephone, but only 9% had no TV, which shows how much of an impact television had on people's lives, because they're sacrificing it over an indoor toilet. So television is a way of sending and receiving moving images and sounds over wires or through the air by electrical impulses. The TV camera will convert the images into electrical impulses, which are sent along the cables or by radio wave or satellite to a television receiver, where they are changed back into a picture. So television has become such an integral part in homes in the modern world that it's hard to imagine a life without them. Different experiments by various people in different fields that led to the first sign of television, which was in the late 1800s. Then we get to pre-1935. So in 1926, the British inventor John Logie Baird succeeded in transmitting. In 1926, the British inventor John Logie Baird succeeded in transmitting moving pictures through the mechanical disc system, which was created by Paul Nipkow. The Nipkow disc, which spins at high speeds, picks up different parts of the image due to light. So the Nipkow disc has dots, like hollow dots each, all the way around at different levels, like one will be high, low, and then it'll continue all the way around. And then light is projected. So as each hole in the disc passes by, it scans one line of the image, which is reproduced, and then it produces the image. So this is the first known image created by the Nipkow disc and the mechanical TV. So Baird's disc only had 30 holes in it, producing an image with only 30 lines scanned, so the picture quality wasn't the greatest, but it was just enough to recognise a human face. And then by 1935 it got to 240 lines, so it was a better quality, but by then the electronic TV was created, which was from 1935 to 1941. So initially the electronic TV was only available in black and white, even though experiments for colour began in the 1920s. However, there was no colour television until 1953. So electronic television started in 1934, which it was created by Phileo Taylor Farnsworth, and it used the cathode ray tube, which is the basis of all modern television cameras and receivers. In a cathode ray tube, phosphor coats the inside of the screen, so when the electron beam strikes it, the phosphor in the screen starts to glow to create the image on the other side. So when the electron gun projects to the phosphor, it causes the spot to race across the screen from left to right, and from top to bottom in a sequence of horizontal lines called the raster. So the spot moves in a pattern similar to your eyesight, so it'll go across and then back, across and then back, but it's done at such a rapid rate that your eyes can't see it, so it's a constant image over the entire screen. So for black and white, the screen is coated in white phosphor, so this is a colour television because it's got the red, green and blue. And then the electron beam paints the image onto the screen by moving the beam across one at a time. But only one electron gun is used for black and white imagery, whereas for colour, like this one with the red, green and the blue, they use three different electron guns. So there's a colour for red, green and blue, which is the RGB model. They also have the interlacing technique, which means odd and even lines. So say they'll scan the odd line and miss out the even, so the picture quality isn't as good. First television colour broadcast, which was in 1967 on BBC Two for Wimbledon. It was broadcasted using the PAL system.
Championship point for the third time for Labour.
In July 1967,
He oversaw the launch of Europe's first colour television service.
So then on the 15th of November in 1969, colour broadcasting went live to the remaining of the channels, which was BBC One and ITV at the time. But colour TV sets didn't outnumber the black and white sets until 1967 due to the high prices when they first came out. So by 1969 there were only 1,000 colour sets used, but by the end of 1969 this had doubled to 200,000, so it was increasing in popularity. So that covers 1950 and 1959 as well, when there was colour TVs and remote controls which were launched. So these are different types of television. So I've mentioned the cathode ray tube. So now I'm going to just mention a few others. So there's liquid crystal display, better known as LCD. So the LCD televisions, they're a lot thinner and lighter as opposed to the first digital ones, which had the cathode ray tube, which were quite bulky and made them big. Whereas these screens could be flat screens. This is an example of the pixels times 3 by 300, so you can tell how small they are. So how it works is light's reflected onto the mirror, which reflects onto the polarizing film, which filters through and then displays onto the positive electrode. It's 3D. So with 3D it takes two images like the human eye, so it takes one from the left angle, one from the right angle, and they are processed together via a 3D processor. Then it's encoded and transmitted to people's televisions through the satellite. But to view 3D images you have to use special glasses which can be used to pick up the different colours. So now I'm going to cover widescreen and HD televisions. So initially televisions started off at 4.3, so they were more square as opposed to widescreen like we see today. The thing with widescreen is it's more natural for viewers. So the thing with widescreen is that's so the old TVs used to be 4.3 and the new TVs is 16.9, which is the ratio of size. So the 16th in width and then 9 in height, whereas it used to be more of a square shape as opposed to wide. So as you can see there, HD is generally 1080p, which is around 2,073,000 pixels, or there's the 1080i, which is not as good as the 1080p, which is interlaced, as I mentioned before, how they skip a line, so the quality isn't as good, but less bandwidth is used. After the advances in television, there was other consumer products that were introduced. So there was the digital video recorders. So initially we used to have video VCRs, which you could set up and leave the house and it'd tape onto a videotape. But the problem with that was you have to set the timer before you left, you'd have to ensure that the tape was clear and things like that. Whereas with DVRs nowadays, you can record television shows with the touch of a button, you can record series, and they're just increasing in popularity. Like Sky's recordings were up by 63% year on year, so it just shows the popularity. DVRs began in 1999 with Replay TV and TiVo, which initially people weren't really interested in, but as time went on they increased in popularity. DVRs also can store more than VCRs could, because with VCRs you'd have to have the actual videotape, so you'd have rooms full of videotapes if you wanted to record series and things like that. Also with DVRs there's on-demand viewing, so you can view things as they happen, and then you can also go into the menu screen and see what you've missed and then just press on it and you can view it on demand. There's also the pay-per-view option where, say there's been a recent boxing match, you pay a fee of about £20 or something like that, and then you can watch the match at your home. It's good for if you like go on holiday and you want to leave and you can put it on series record, so you've got all the series and you come back. You can also, with Sky Plus and things like that, you can also pause live TV, so if you wanted to go make a cup of tea or something, you can go back. And then there's the option to catch up with BBC iPlayer, Sky Plus and Virgin Media and things like that. Smart TV is more interactive, so if you have apps, internet, you can stream videos on them, so it's basically like a computer but in your TV. You can do generally apps that are already downloaded or things like services such as like iTunes, Netflix, HBO Go, things like Apple TV and things like that can also be used as a alternative to having the actual TV. You can plug that into your TV and get the same effect. Being advances in technology with this, with a cloud-based service, so no matter what you want to find, you can go on the cloud and get old TV shows, old movies that have been recorded and just stream them through your television. So as you can see, they mentioned there about films, music, streaming on the internet, like going onto things like Facebook, Skype, all things like that can be done just on your TV as opposed to getting on your laptop or on your phone as people do nowadays. So brought out in 2013, so it's relatively new. There was the invention of the curved TV available to consumers. The advantage of the curved TV is with its curve it improves the immersion into TV, so you feel like you're actually in the TV. It gives you a better sense of depth and it's a wider field of view. So, but there's some problems with having a curved TV, like you have to be sat in the middle to get the best viewing experience as opposed to normal TVs where you could be sat. As you can see there as well, it's Samsung curved ultra high definition TV, which is another thing. So with ultra high definition TV, it's 3,840 times 2,160 pixel resolution, which is compared to HD, so it's double the pixel.
Popular Science presents a backstage preview of television, the newest miracle of modern electrical engineering. Technicians in the Farnsworth, Philadelphia laboratories have helped to make television, the dazzling dream of the decade, a practical reality today. Mr. Philo T. Farnsworth, shown at the right, is working on the image dissector tube, a photoelectric camera tube of his own invention that distinguishes his system of television from others. It is said to be responsible for the most clearly defined television pictures. Placed in the circuit of this receiving system is a funnel-shaped cathode tube. The round, flat surface of its bulb becomes the picture screen in studio monitor sets, as well as in home receiving sets. The image dissector tube and the cathode oscillite tube are the heart and brain of the Farnsworth system. Television engineers are now adjusting studio equipment to demonstrate the technical routine of broadcasting a television program. Max Factor Jr. has developed a new type makeup for television photography. The photoelectronic camera, being supersensitive to red, causes that color to be absorbed. Thus, red is applied to hollows and depressions of the face to eliminate heavy lines and also to produce highlights, while blue, which reproduces darkly, is used as eyeshadow. The facial makeup of the modern movie queen makes her a dream of loveliness, but the television star has the grotesque appearance of a circus clown. The new television makeup may give the camera a break, but the wearer's first view of herself is likely to break her heart, unless she has a sense of humor. In this camera is an image dissector tube. The camera lens picks up the artist as an image of light, causing electrodes in the dissector tube to emit electrons. Passing through station equipment, the electrons become radio impulses to be broadcast and picked up by receiving sets where the routine is reversed. The radio impulses becoming points of light that appear on the screen as pictures. 30 pictures are completed every second. These pictures are composed of 200,000 light points that strike the screen one at a time at the rate of 6 million points per second. Music and sound accompany the performer's action, both visible and audible elements going on the air in perfect synchronization. As the action is photographed from various angles, engineers at control boards select long shots and close-ups, editing the show as it passes instantly through the station's facility. Traveling with the speed of light through a maze of tubes and equipment, the show leaves the station's sending towers to be viewed by the television public, an audience as yet small and comparatively ignorant of the enormous research and experiment that makes it possible for us to see and hear people many miles away. We can even see the announcer, although that annoying necessity is still protected by distance. The camera swings round in the next act. While radio can portray the art of the ventriloquist, television makes it possible to witness the magician's sleight of hand from a distance for the first time. Silent, invisible, instantly, human speech, music, and appearance pervade the airways together, to be received in magic boxes for distant reproduction. It may not be long before news events and current world happenings will be witnessed in thousands of homes. Television may picture for those at home the work of far-off explorers, or it may reveal to military officials the details of distant maneuvers. The most fanciful dream of mankind is today a startling reality, destined to become the world's most popular science.